In the name of God. Hello, dear students. Welcome back to Ferho's website. My name is Masoud. I'm a physics teacher. In previous lessons, we explained, let's say, some topics about chapter 2. And especially the last lesson, we talked about types of object. There are two types of object. Either we have extended object, and it's the object that rotates about itself, right? And or we have, let's say, point mass, and it's an object that, let's say, that has only translational motion. And you know what translational motion is? Translational motion means the motion of an object that shifts its position, let's say, continually, right? It changes its position continually. This is called translational motion. Right, so there are some questions in this lesson. I prepared them. There are 4 questions about the types of object. Let's discuss them together. Question number 1. An extended object has rotational/translational motion, but a point mass has rotational/translational motion. So I want you to choose the correct, let's say, the correct choice, right? Choose the correct answer. It says an extended object. So extended object has rotational motion or translational. Of course, it has rotational motion. I told you, extended object is associated with rotational motion, right? So, but a point mass has translational or rotational. Which one? Guess the answer. I'm sure you know the answer. So it has translational motion, right? So I can say point mass has translational motion, but let's say extended object, only they are, let's say they are rotated, right? They have rotational motion. Question number 2, center of any spinning object. Center of any spinning object is it's just a point, right? It's a point. Center of any spinning object has translational motion. Yeah, it mentions it. That only has a translational motion. So it has only translational motion, you see? And treated as a point mass. Center of any spinning object is considered, let's say, as a point mass, right? And is called what? This center, and is considered to be a point mass, is called inertia or center of mass. Inertia or center of mass. Of course, it's clear from its name, center of any spinning object means center of mass. That's why this option is true. Center of mass. So either, let's say, let me tell you, however, you have a spinning object. For example, you have a spinning bowling ball. You have a spinning pin, right? These spinning pins and spinning bowling ball, actually, they are all considered to be extended objects, right? But let's say one point of these objects actually does not rotate. The center of this object, however, they rotate, right? The objects rotate, but one point of the object, and this point is exactly the center of mass of the object, does not rotate. So one point, let's say, within any spinning object has a translational motion and it does not rotate. This point is called center of mass. Question number 3. In bowling, let's say this is a game. This game is called bowling. There are some pins, and you throw a ball, let's say, very, very heavy ball, which is called bowling ball actually, toward the pins, right? So it says in bowling, dash or space can be treated as an extended object. So which one can be treated as extended object? Bowling ball itself is considered to be an extended object, or let's say spinning pins, pins. So which one? It says in bowling, space or dash or gap can be treated as extended object. Which one? A, each pin, it's true, right? Because whenever the bowling ball strikes the, let's say, pins, the pins fly backward. The pin, let's say, rotates about themselves. That's why they don't have a very simple motion, because the ball is very heavy, and whenever the ball strike the pins, even there are collision between the pins themselves, right? They collide with one another and they strike the ball. That's why they are not considered, let's say, point mass. They are considered to be, let's say, extended objects. So pins is true. Each pin is true. The bowling ball, of course, the bowling ball is considered to be a, let's say, extended object, because whenever the person strikes the bowling ball, or the person throws the bowling ball toward the pins, because of friction between the bowling ball and the surface. That's why the bowling ball rotates. It does not slide across the, let's say, across the surface. That's why it let's advances, let's say, forward and rotates simultaneously. That's why bowling ball is considered to be extended object. C, it says A and B are true. It's true. D, none of these. I can say so. Each pin and bowling balls actually are considered to be, let's say, extended objects. Number 4, the last question about the types of object. In bowling, in this, let's say, sport, this game, in bowling, pins and bowling balls have space motion. There's a gap here. We have to fill in the gap with an appropriate expression. So guess the, let's say, correct expression. In bowling, pins and bowling balls have A, rotational motion. Yes, they rotate. B, translational motion. They change their positions. C, A plus B. D, circular motion. So circular is not true. That's why A and B are true. Right. So that's all, guys, for today. Thank you very much for watching this video, and bye for now.